Alright, let's look at the homework 7.1, problem number 8. Alright, so we're going to use the shell method to find the volume. Alright, so let's do that. Alright, first we have to sketch the region. Alright, so here's my y-axis. Oh, actually x-axis. And here's my y-axis right here. Alright, and here's the origin. Alright, so 5e to the x, so that's just an increasing exponential function. So it's going to go through 5, so maybe I'll put maybe 5 around here. Alright, then more or less just increasing exponential function, so it looks kind of like that. Alright, and 5e to the negative x would be a decreasing exponential function, so it will look it's actually a mirror image, right, like that, right? And then x equals 1, so 1's probably, I'll just put 1 here, right? Then so you have a vertical line there. Right, so I meant 1, not x. Let's see, I'm gonna clean up a little bit. Here is 1, and then you have a vertical line there. All right, so we have a region right here, and we're gonna rotate it about the y-axis, so it's gonna be that. Alright, so let's draw approximating shell, cylindrical shell. So I'm going to take that. So this is going to be my sample X. Right? Then cylindrical shell is going to look something like that. Alright? So you can see that the radius is going to be just x, and the height is going to be, height is right here, right? So that's just the difference between, so I'm going to just say a height, I'm going to call it h, is going to be difference between 5e to the x and a minus 5e to the negative x, right? So we have that. And then, so that's that. Let's set the volume integral. All right, so volume that we're looking for is going to be, so it's a cylindrical method. So we have 2 pi, and the integral is going from 0 to 1, 0 to 1. And the radius is going to be x, so x is the radius. And the height is, as I said, it's a let's pull out 5, so it's a 5 times e to the x minus e to the negative x, right? Dx, right? If you want, we can actually turn this into hyperbolic sign. So remember, if you have e to the x minus e to the negative x, if we had over 2, so we divide by 2, multiply by 2, so I'm going to squeeze 2 there, so it's 2 times 5, right? Then this is this guy is actually hyperbolic sign of x, right? So let's put that in. So we have, alright, I'm going to pull out the numbers. So 2, 5, so it's 10. So you have a 20 pi. So we took care of 2 pi. Oh, actually, let's use a different color. We took care of 2 pi and 2 times 5. Alright, then inside we're going to just have integral from 0 to 1 x. And then you have a hyperbolic sign of x dx. All right. Then we can just do the integration by parts. So this is the first guy. This is the second guy. So take the derivative of the first guy, you get 1. Take the antiderivative of hyperbolic sine, you get hyperbolic cosine of x. Right? Then this is going to give us, right? So 2 pi is just 20 pi, I should say. 20 pi is just a number. Right? Then we have to do an integration by parts. So multiply this way. So we have x times the hyperbolic cosine of x, and we're going from 0 to 1, minus, then integral from 0 to 1, and we multiply sideways, so it's a hyperbolic cosine x dx. Alright, then we can just plug in numbers and see what we get. So you have a 20 pi. Alright, let's plug in 1. So 1 times hyperbolic cosine of x. So hyperbolic cosine of 1. And minus, if you put 0, so that's 0. So that's that. Alright, minus, right, antiderivative of hyperbolic cosine is hyperbolic sine of x. Then you're going from 0 to 1. Right? Then you get, let's see, 20 pi. Right? Then we have, right, hyperbolic cosine of 1, right, minus hyperbolic sine of 1, and maybe I'll put it in a bracket, minus, plug in, hyperbolic sine is going to be actually 0, so 0. Alright, so therefore, what you get is it's a 20 pi. Then you would have simply hyperbolic cosine of 1 minus hyperbolic sine of 1. Right? So that would be the volume of the solid that we're interested in. Right? So let's type this guy in. Alright, so we found that to be 20 pi, then parenthesis, right? We have a hyperbolic cosine of 1 minus hyperbolic sine of 1. Alright, let's see. Well, that doesn't look... Oh, is that right? Yeah. Alright, so is that what? Let's see. Yep. So let's check the answer by submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.